Welcome back, physics fans. Here we are, number 6 on the momentum and impulse worksheet. A return of the Jedi lunch bucket is sliding across the floor at 4.3 meters per second, and it has a mass of 400 grams. 1.3 seconds later, it is going at 2.1 meters per second. It started slowing down. Okay, calculate the change in momentum, calculate the force of friction, and calculate mu. So the change in momentum is mass times the change in velocity. It's because momentum is mv. And the mass is 0.4 kg. That's the mass of it. And the velocity, it's going to be Vf minus Vi. So Vf is 2.1 meters per second, and minus Vi, which is 4.3 meters per second. These are both in the same direction, so we don't have to worry about the directions. We can just literally subtract. And at this point, this will be 0.4 in kilograms. And 2.1 subtract 4.2, I believe, is 2.2 meters per second. But this is going to be negative, as the change in momentum will be decreasing as the velocity decreases. And this will be a negative 0.88 kilograms meters per second. So that's its change in momentum. Now, the negative represents a direction, so we should, and this is supposed to be a vector, so realistically you should say 0.88 kilograms meters per second backwards. Okay, calculate the force of friction. That's a weird one because we have a free body diagram that I'm just going to quickly sketch here, and a force of friction. And we're supposed to calculate that. And that's so previous chapter. How do we do this? Well, that means the net force is the force of friction because that's the direction of the acceleration. Yet it's moving this way, the acceleration's that way. So we're going to have to find what the F net is because the net force is the frictional force in this case. And the net force is from impulse. Impulse is the force, the net force, times the time, and that's equal to the change in momentum. We have the change in momentum, so F times the time, which is 1.3 seconds, is equal to the change in momentum, which is 0.88 kilograms meters per second. So pull up Mr. Calculator, and we will go 0.88 divided by 1.3, and we get that the force, because I'm using the impulse one, is 0.88 divided by 1.3, and that's going to be 0.677, 0.677 newtons, and that too will also be backwards. Why is that backwards? Because this change in momentum was backwards. And we anticipated that will be the force of friction, because this is the net force, which is equal to the force of friction, as we up here. So this that we just highlighted yellow is the force of friction. And of course, we understand it to be backwards. It's opposing its motion. It makes sense. So that equals the force of friction. And if that's the force of friction, and we know that's equal to mu mg, we could calculate what mu is, which is part C. The force of friction is 0.677 newtons. And we're going to calculate mu. We know the mass is 0.4 kg, and g is 9.8. So mu is going to equal 0.677 divided by 0.4, and also divided by 9.8. So we pull that up on the calculator and take this and divided by 0.4 and also divided by 9.8. And we get that the coefficient of friction that's actually happening here, 0.173. So I'm going to highlight that answer. That's the other answer and the first answer. So those are the three answers. I'll actually probably make that one is the answer. Dun, da, da, da. There we go. Thank you very much. Enjoy.